Hi, welcome to my presentation. For today's activity, I will discuss three topics: the fundamental primitives, objects with meshes, and parametric surfaces. Fundamental primitives. In computer graphics and geometry modeling, fundamental primitives refer to the basic geometric elements used to represent and manipulate shapes and objects. Number 1. Points. A point is the most fundamental primitive in geometry, representing a specific location in space. Points have no dimensions, they are simply a position or coordinate in a coordinate system. Points are the building blocks for constructing more complex geometric shapes and objects. Defining a point is simple. You just need to specify a 3D location. For example, this point is at 0.4 in x, 0.2 in y, and 0.0 in z. Number 2. Lines. A line is one-dimensional primitive that extends infinitely in two opposite directions. Lines are defined by 2 points, a starting point and an ending point, or by an equation. Lines have direction and can be used to represent edges, boundaries, or paths in geometric constructions. Number 3. Polygons. Polygons are two-dimensional geometric shapes composed of a finite number of line segments that are connected at their endpoints. Polygons can be classified based on the number of sides, such as triangles, quadrilaterals, pentagons, hexagons, and so on. Polygons are fundamental building blocks for more complex shapes and surfaces in geometry and computer graphics. For the second part of this presentation, I will discuss objects with meshes. A mesh is a collection of vertices, edges, and faces that define a shape and surface of a 3D object. Meshes are widely used in various applications including video games, computer-aided designs or CAD, visual effects, and virtual reality. Here are some key points about objects with meshes. Number 1. Vertex-based representation. A mesh is composed of vertices, which are the basic building blocks of the 3D object. Each vertex has a specific position in 3D space defined by its x, y, and z coordinates. Number 2. Faces and edges. The vertices are connected by edges, which form the boundaries of the faces. Faces are the polygonal surfaces that make up the object's shape, typically triangles or quadrilaterals. Number 3. Polygon meshes. The most common type of mesh is a polygon mesh, where the faces are made up of triangles or quads. Polygon meshes are widely used because they are relatively simple to process and render, and they can approximate complex shapes effectively. Number 4 is smooth surfaces. To create smooth surfaces, meshes can be combined with techniques like subdivision surfaces, or NURBS, or non-uniform rational B-splines. These methods allow for the creation of smooth, organic-looking shapes from a relatively simple mesh. And lastly, texture mapping. Meshes can be combined with texture maps, which are 2D images applied to the surface of the 3D object. This allows for the addition of detailed surface patterns, colors, and materials of the object. And for the last part of this presentation, I will discuss parametric surfaces. Parametric surfaces are a powerful way to represent and model complex 3D shapes in computer graphics and geometric modeling. A parametric surface is defined by a set of mathematical equations that describe the surface's shape and properties. Here are some of the key aspects of parametric surfaces. Number 1. Parametric equations. Parametric surfaces are defined by a set of parametric equations, typically in the form of x times u v, y times uv, and z times uv, where u and v are the surface parameters. These equations describe the position of the surface in 3D space as a function of the parameters u and v. And number 2, surface properties. Parametric surfaces can be used to represent a wide range of shapes, from simple planes and cylinders to complex, freeform surfaces. The parametric equations can be designed to control the surface's curvature, smoothness, and other properties.